In this video, we will talk about the matrix addition. So let's look at the definition. So for two matrices A and B of the same dimension, if you have two matrices A and B whose dimension is same, for the dimension means if A has m number of rows and n number of columns, then B must have the same number of rows and m number of rows and n number of columns. So I will denote it by r to the power m times n. Here m refers to rows and this n refers to columns. Right? So if you have m number of rows and n number of columns for A, then same thing would be for B also. So both matrices have the same dimension. Then you can add both matrices and you will get a new matrix which is C. And how you will write the entries of C? So the entries of C, so the ith row and the jth column entry of the matrix C can be obtained as by adding the ith row and the jth column entry of A with the ith row and jth column of B. Okay, Aij plus Bij. For example, at ijth position of A and ijth position of B, if you add them, you will get the ijth position of C. Okay. Here is the example. For example, you have two matrices A and B. Okay. So you have to add them. So for example, matrix A denotes the sale and matrix B also denotes the sale. Then the total sale is obtained by addition of two matrices A and B. So first of all, I will add A1 one of this and A1 one of this. First entry of this and first entry of this. I will get the new element here. Okay, 63 plus 86. And similarly, A12 and B12. So I will add them, 24 plus 33, and then I will add these two entries. You will get here, and then we will add these two entries. You will get here, and for the next one, you will get here, and the last one, 98 plus 102, you will get here. So after the simple calculations, you will get this matrix. Now we have some properties of matrix addition. So the first property is commutative property. So what is meant by commutative property? It means that if you add A to B or you add B to A, you will get the same answer. You will always get the equality. And the next property is associative property. It says that if you add three elements, but in such a way that if you add first A and B and then C, or if you add B plus C first and then A, you will get the same answer. Okay? So the next property is additive identity. What is this property? If you add zero matrix to any matrix, you will end up with the same matrix. That means, for example, you have this matrix 0, 1, 3, 4. If you add here 0 matrix, you will again get this matrix, right? So the last property is, if you add negative of A in A, then it's just like if you add 5 plus minus 5. So what will you get? Very simple answer is both will be cancelled and you will get 0. Okay? So similarly, if you add the matrix A with its negation or the additive inverse, both will be cancelled. You will get the 0 matrix. Okay? Instead of 0 number, you will get a 0 matrix because we are dealing with matrices. Okay? Next, you have scalar multiplication. So if you have a real number R and a matrix A, then you can multiply this scalar with A in such a way that R times A is equal to R is the scalar and A is the matrix. If you put the value of this matrix in this way, this is arbitrary matrix which we has assumed in the very first video. So if you multiply this scalar with this matrix, then this R will be multiplied with each of the entry. Okay? So that means you will multiply R with all of these entries and then you will multiply R with all of these entries and then with all of these entries. So this is all about the matrix multiplication. Here is an example. Let A is a matrix. Then if you want to multiply this matrix with a number, for example 1.5, you can take any number. So if you multiply this matrix with 1.5, you will get this matrix. Now we see the properties of scalar multiplication. So if you have two matrices A and B and there are two scalars R and S, because we are doing scalar multiplication, so therefore I have considered the matrices as well as the scalars. Okay? So first property is the distributive property over the matrix addition. What's meant by this? If you have a scalar and there are two matrices which are being added and there is a scalar which is being multiplied, then this scalar will be multiplied with this as well as it will be multiplied with this. So I have multiplied R with both. So the next property is the distributive over scalar addition. What's meant by this? So in the previous property was the matrix addition and this property is the scalar addition. So previously the matrices were being added, but this time instead of matrices we will add the scalars. Okay? So suppose you are adding scalars and then you are multiplying the addition of those scalars with the matrix A, then each scalar will be multiplied with the matrix A. I mean R will be multiplied with A and S also. This is called distribution over scalar addition. The next property is associative with respect to the scalar multiplication. What is meant by this? If you have two scalars and they are multiplied, so what is meant by associative with respect to scalar multiplication? This means if you first multiply both scalars and then multiply with A, or you multiply S with A first and then you multiply R with the result, you will get the same answer. Okay, these are the properties. Now let's solve an example which will contain all of the previous properties as well as the scalar multiplication and the matrix addition also. Let us have an equation and we have to solve that equation for x. The equation is this one. So we have this equation and we have to solve this equation for x. Let's solve it. So the first target is to move this 2x to the left side of the equation. Since this is negative, so when you will move it here, it will become positive, okay? And simultaneously, you will move this negative matrix to this side also, and it will also become positive, okay? So you will have x plus 2x, x plus 2x. This is x and this 2x, okay? So x plus 2x is equal to this matrix plus this matrix. You can see I have added both matrices. Because this matrix is negative, and if you move it here on the right side, it will become positive. So that's why I have written plus. Now if you add both x plus 2x, you will get 3x. And if you add these two matrices, you will write this kind of matrix. 2 plus 4, 1 plus 1, and 1 plus minus 1, and 0 plus 2. And you will end up with this matrix after the addition. Now you have to solve it for x, but here you have 3x. So you need 3 to this side, okay? Because you need here only x. What will you do? You will do, since 3 is multiplied with x, so if you move it, shift it to the other side, that means you have to divide for 3, okay? So how will you divide for 3? So that means if I don't need 3 here, I have to divide 3 with each term, okay? If I divide it, I will end up with this answer.